Alrighty. Let's take a look at this. A lead-acid battery has an EMF of, this is a fully charged one, right? Internal resistance of about 23.7 milliohms, right? So our little resistance is 0.0237 ohms, right? So if we made that into milliohms, we go 1, 2, 3, right? So that's our little thing. And then our EMF is equal to 12.72. And then we know that I times R is equal to 11.85. Right? And then it's asking us for what R is. What is R? All right. Well, that's going to be interesting, right? How do you do this? I don't know. Let's just look at the formula. Let's try the one that they give us, right? So EMF is equal to I times R plus R. So it helps that we know, right, that the terminal voltage is just I times R, right? Okay, so let's distribute this. EMF is equal to IR plus I little r. Okay. Does this help? It might help. Oh, you know what? I bet we can find the current this way. Let's do it. Okay, so the EMF is 12.72. That equals the terminal voltage, right, is IR. So that's 11.85. Oh yeah, we can do it. This is good. I'm glad we wrote that down. Okay, then whatever the current is times 0.0237. That's good. Now the only thing we don't know, right, is that current, right? So if we know that current, we can figure out what the resistance of the external circuit is. Okay, let's do this. I don't know. This cannot be solved. 12.72 minus 11.85. It's 0.87. Then I'm going to divide by 0.0237. And I've got that the current is 36.70886. 36.7. Okay, I have to use that exact precise thing, right? So that's my current. Now we know that I times R is 11.85 volts, right? We know that I is equal to 36.70886 amps. So therefore, IR divided by I is going to give us our R, right? Okay. So let's see, 11. So R is equal to that, right? So that's going to be 11.85 divided by 36.7088. I'm going to use all the precision of it, right? So I'm going to go 11.85 divided by the answer that I just got. And I get that resistance of the external circuit is 0.3228. So I'm going to say 323 ohms. All right. If you stay tuned now, I'll show you another way to do this. Okay, I'll show you another way to do this just for kicks. All right. All right. Another way to do it, right? Let's just go back to our idea that the terminal voltage is EMF minus I times R, right? Okay. Yeah. So now we can go 11.85 equals 12.72 minus the current times 0.0237, right? I don't know if this will make more sense. This is the way I initially did it, right? Minus 12.72 divided by negative 0.0237. And again, I get that the current is equal to 36.70886, right? Which means that the total resistance of the circuit, the total resistance is going to be the EMF of the battery, right? It's just 12.72 divided by as I do this, I realize this is not the best way to do it, but let's just go with this, right? So 12.72 divided by that guy. This might make sense to you. I don't know. It made sense to me. So the total resistance of the battery is 0.3465,103. That is equal to R plus R, right? Yeah. And then if we just subtract the resistance of the cell itself, 0.237, we'll get the resistance of the external circuit. It's a crappy way to do it, probably. 0.323 ohms. Did this make more sense? The other way probably made more sense. All right, I don't know.